Hi everybody, it's Miss Sarah. Last week we learned about simplifying radicals and how to write radicals in their simplest form. This week we're talking about special right triangles, the two triangles, right? The 45, 45, 90 and the 30, 60, 90. And both of those triangles have ratios that have radicals in them. So we're going to want to keep making sure that we write our answers in simplest form. And simplest form means that there's not ever a radical or a square root in the denominator of a fraction. So this means we're going to have to learn a new skill called rationalizing the denominator. And that gets rid of any square roots that we might possibly ever have in the denominator of our fraction, okay? So we're going to need to learn this skill because when we write our answers, we cannot have a radical in the denominator of a fraction. So there's only two cases where you're going to come up with this scenario, right, with the radical in the denominator. And case one is in the 45, 45, 90 triangle. So case one, we have a 45, 45, 90, right? Let's say it looks something like this. There's our 90-degree angle. These are the legs, and let's say we know the hypotenuse. We know the hypotenuse is 8. Okay, so this is case one, where we are going to have to rationalize the denominator to get rid of the square root in the denominator. Okay, so here's my example. We have a hypotenuse of 8, and the question I'm asking to you is, well, let's find the legs. And we know the legs are the same, so we can just find one of these, and that'll be the answer for both. So we have a 45, 45, 90. Let me put these angles in here. With a hypotenuse of 8. So the standard ratios of a 45, 45, 90 tell us that when we go from the leg to the hypotenuse, we multiply by the square root of 2. So to go from the leg to the hypotenuse, we are multiplying by the square root of 2. Well, that means to go from the, get a different color, to go from the hypotenuse to the leg, well, instead of multiplying 2, we're going to have to do the opposite operation. So to go from the hypotenuse to the leg, we are going to be dividing by the square root of 2. Okay, so that's what we're going to have to do with here. So we're taking our hypotenuse. Our hypotenuse is 8. Okay. To get one of the legs, we need to divide by the square root of 2. Well, if I didn't teach you how to rationalize, we would just circle this and call our answer 8 radical 2. But I just told you, right, we cannot have a radical in the denominator of a fraction. So we're going to rationalize. And what I mean by rationalize is we have to cancel out this square root in the denominator here. So what I'm going to do is I'm going to multiply this fraction by 1, right? I need to multiply it by 1 over 1. Well, if I put the square root of 2 here, the square root of 2 times the square root of 2 will give me the square root of 4, which is just the number, plain old number 2. Right, but whatever I multiply the bottom of my fraction, I need to multiply by the top, so I'm going to multiply by the square root of 2 over the square root of 2. This will help me to cancel out the denominator. It'll give me a number. Square root of 2 times the square root of 2 is the square root of 4, which is just the plain old number 2. So I'm all set in the denominator. I don't have a square root here anymore. And then here, well, we can't really combine anything up here because we have a number and a square root, so these just combine like this. We have 8 radical 2 over 2. And I'm still not yet done, right? I want simplest form. 8 over 2 simplifies down to what? We have 4 radical 2. And that is my answer. So both of these legs are 4 radical 2. Instead of starting with this, I do not want to write 8 radical 2. I want to simplify down until I get no square roots in the denominator, and my final answer is 4 radical 2. Okay, that's case one. That's the only time you're going to have to rationalize when we're dealing with a 45, 45, 90 is when going from the hypotenuse to the leg. All right, let's talk about case two. Case two is when we have a 30, 60, 90 triangle. Say it looks like this. We have 30 down here, 90, 60. So the case that happens here is when you're going to have to rationalize is when you know the length of the big side. So the length of the big leg is across from the 60-degree angle. So let's say the length of the big leg is 18, and we need to find the length of the small leg. Let's call that x. Okay? So normally the ratios tell us, well, when we have the small leg, to get the big leg, we multiply by the square root of 3, right? Now we're going the opposite way. We're going from the big leg to the small leg. That means we're not going to be multiplying, we're going to be doing opposite operations. I'm going to need to divide by the square root of 3. Okay, I'm dividing by a radical, which is where the rationalizing comes in. I'm taking 18. I need to divide by the square root of 3. Right, we do not want to leave our answer like this because we have a radical in the bottom. We don't want radicals at the bottom. So what I'm going to do is multiply by the square root of 3 over the square root of 3. Just 1. 18 times the square root of 3, we just combine those. But here, well, the square root of 3 times the square root of 3 is the square root of 9, which is just the plain old number 3. So that helps me get rid of this. And I can simplify this even more. 18 divided by 3 simplifies down to 6 over 1. So my final answer is 6 radical 3. And that is the length of my small leg. Okay, only 2 cases in special right triangles where you're going to have to deal with rationalizing the denominator. These are the 2. Let me know if you have questions. Thank you.